Welcome back, and now we are talking about quantum mechanics. In our last topic, we spoke about the infinite square well and how we could use that to trap the location of a particle which normally exists as a wave. So we know the fundamentals thing that's going to be running through quantum mechanics is the idea that there is no real such thing as a particle. They are basically just waves that once interacted with in a certain way look like particles. What is it with you and Skyrim and Gabsmacked? Oh, that's so bad. You're gonna hate me, man. The amount of times you go into Skyrim. All right. So what we spoke about before, we spoke about the infinite square well. Okay, so I highly recommend, if you haven't seen that, to go back and look at it and then come back and watch this. But you can try and follow along, and most people here are pretty damn smart, so you'll probably follow along. All we did in the first one was to create a mathematical representation of how to understand where a particle is along its wave function. And we used an infinite square well so that we could find out where it was easily. Now we're going to complicate the mathematics a little bit by showing a finite well. Now I'll show you what it looks like. Here is the infinite square well, and we mentioned in the last, if it decides to zoom in. All right, yeah. So as we can see here, these are the energy levels at which the particles can exist. And remember that the universe at a small scale is pixelated. The universe at a small scale is pixelated. We are made of pixels. It is not a continuous flow. And so when you energize a particle, it can Skyrim Gabversity. Oh, that's awesome. Oh, really? Oh, cool. So when you add energy to a particle, instead of going up, it actually disappears and reappears up here. And we spoke about that in the last one, where we said if you go in an elevator, right, when you go up to floor 1, normally you can see yourself moving up if it's a glass elevator, right? But on the quantum level, we actually start at ground zero and then disappear and reappear at number 1. And no one knows why that happens, but that's what happens. So the universe is pixelated, just like screens. Computer screens are all pixels. And when you zoom out, it just looks like a picture, but when you zoom in, it's all dots. And that's exactly what we are as humans, as everything in the universe. We're all just dots when you zoom down small enough. Which is very weird. So in a finite square well, the mathematics increases. And I'm going to show you what it looks like. All right, so here we have what you call V of x. V of x is the potential energy, and x is the particle itself. All right, and it's 0 if the absolute value of x is less or equal to a. And it's V0 if the absolute value of x is greater than a. That is the mathematics, and here it is. So what we're saying is that in here, that's the level, potential energy level at 0. Up here, why does the space get bigger if I... Why does the space get bigger? Oh, are these ones? Do you mean here, 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 and here? Is that what you meant? Like when you energize a particle? Oh, yeah. Well, what happens, no one knows why. So these are the fundamentals of quantum mechanics, that this is as far as we possibly know as humans so far. We know that when you energize a particle, its energy level doesn't go up in a linear fashion. It goes up in an exponential fashion. So imagine if first floor was here, second floor was like here, and then third floor was, you know, that's what happens when you energize a particle. So the gaps get bigger, and in those gaps, nothing can exist, even with mathematics. Mathematics shows that they can exist, but not in this universe. So in this universe, they only exist at certain gaps, which is very bizarre. Anyway, so, but nothing is something. And nothing in terms of physical nothing, yes, which is different to the fact that no existence can exist between particles, like silence. Like silence is actually something, yeah, that's right. That's exactly right. Oh, what? Thank you. That feels a bit better. So here we go. We're going to talk about now, there are two basic possibilities for energy E. Now, remember what I told you about pixels? So on a computer screen, right, you know, when you zoom in, you just see little dots, right? Now, the thing is, those dots, the boundary of those dots on computer screens, in the universe, those dots are the energy packets, okay? And those packets are the finite wells that we talk about. So those wells capture energy and lock it into a particle. And that's the pixel. When you have an unbound state, that is when the wave becomes a general form. In other words, explodes back out, and then you just have a random wave and you don't know where the particle is, and it might not even be a particle. So interacting with the wave makes it a particle, which is very interesting. All right, so here is the mathematics, and if you're not into maths, then just ignore this part. You don't have to get it. Collective energy, very true. So here, as I said in the last episode, right, this is called unbound state. This is where E is greater, and that's when it's just a big random wave. All right, so the wave number K, remember every wave has a special number K, special K, takes the general form this. So that is the square root of 2 times the mass multiplied by E, the energy, minus the potential energy of that particle, all of that divided by the Planck's constant over 2 pi. Okay? And all that is saying that it is quantized. So the reason it's divided by h bar, h is a special number that is for some reason the size of all of the pixels in the universe. So the smallest possible particles or energy packets appear in these little pixels, and the size of those pixels we call h, and it's called Planck's constant. It was developed by Planck himself, I think in the 1900s at some point. These people are freak geniuses, man, honestly. So the wavelength is shorter inside the whirl. A possible wave function might look like one in figure 5. All right, this is interesting. So if you imagine that, okay, so I'll give you an example. Imagine that you have just air blowing around and you can't hear it, but as soon as you get a tube and you blow air near the tube, you know, like an empty bottle, you go, and it goes, and it makes a sound. But when you move the bottle away, it's just air. Exactly. That sound, right, that is a perfect analogy to us as matter. So matter, when you blow that wave around certain things, it creates the illusion of matter. So we're just like sounds, and all different matter is just different sounds. That's all we are, right? So you can capture things by observing them, which is really weird, right? If you observe a wave, it turns into a particle if you observe it in a certain way. Okay, it is customary to draw the Vx function on top of the E line. So this is what it looks like here. I'll show you. Right. Because the things I'm showing you are for those who are really into the physics from a mathematical perspective. So here is a normal wave. Now when the wave comes over something that traps it, right, it turns into this, which will look more like a particle, and then it comes back into wave again. And that middle section that looks like a particle, that is what we see as particles. So we see light, we see electrons, we see all these things that make us up as matter. It's all just a wave in a certain frequency because it's trapped. Like when you blow air over the bottle, so it's like nothing there, and then, you know, and that sound is us. We're made of sounds. Isn't that amazing? All right, so let's move on. The wave function extends infinitely in both directions. That's the weird part. So basically a particle, when it's in a waveform, can exist everywhere at the same time. So the potential is everywhere, and when you trap it, it comes to that point. That's a weird concept. How does that even make sense? Well, mathematically, it makes a bit more sense. Now we're going to talk about the bound state. Now, for those who are into maths, here's the equation. Okay, so now that equation is going to have a complex number. And what that means, a complex number is when that has a square root sign in the equation. And for anyone who knows basic maths, you can't square root a negative number and get a real number. You're going to get a complex number, which is what we call an imaginary number. But it's really a two-dimensional number. And in fact, those numbers represent parallel universes that we're pretty sure exist. Okay, what's interesting is that those numbers are needed to find an actual particle, which is very weird. So it's almost like particles are fake. So we're sort of fake. We think that we're real, but we're not. Now that the latter value is imaginary, so is an oscillatory function inside the world, but an exponential function outside. Furthermore, it must be an exponentially decaying function outside, because otherwise it would diverge at x equals infinity, since the particle has exponentially small probability of being far away. We call this a bound state. Okay, so that's pretty simple. So all they're saying is that the equation is in such a way that if you trap a particle by observing it, it's probably going to be where you're observing it, right? So it's not possible that you look for your phone. You know your phone's in your house, right? So you're not going to look in your neighbor's house, right? You're not going to look in the house in Australia if you live in the US. So you know that the chance of it being in my house is basically zero. right? But if you look for your phone, if you lose your phone, yeah, common sense, exactly. If you lose your phone, you know you're going to look in your house, in your car. That's called that you're doing it. So even people who think they're not good at maths, you're actually good at maths because you realize there's a bigger chance of me finding my phone if I look in my car, at my work, in my purse or my wallet, my pocket, right? As opposed to looking in my pocket in Australia. You're going to fly to Australia and check my phone on my pockets. Of course, that's ridiculous, right? Now, it doesn't mean it's impossible, because you could leave your phone at the airport and then it goes into the plane and then it ends up in someone's pocket. That could happen, and then it could end up at my place. But it's almost zero possibility. And it's the same with quantum mechanics. When you observe a particle, you know it's going to be somewhere around where you're observing it, as opposed to the other end of the country. That would be a bit weird, but it's still possible. So that's what the mathematics is saying. When you do the equations, it shows we can actually calculate now, or as humans, we can calculate the probability of where the particle will be when we observe it, which is amazing. It's an amazing thing to do, and that's where the mathematics will come in. And I'm going to actually do equations and show you how it's done and stuff. Okay, let's concentrate on the bound state, the boundary conditions given by the following theorem. Okay, so now we're going to talk about bound states. Okay, so a bound state is this. If you lose your phone, right, you know that you are not going to look for your phone outside of where it's probably going to be. So even though there is a possibility that your phone could have ended up at my house, you know that it's going to be basically zero. Yeah, I am not good to help you sleep, by the way. They were surprised initially, yes, they were surprised. In fact, it was black body radiation that showed them that it didn't work, because the mathematics of original classical physics showed that if you lit an inside of an object, the object should shine with the brightness of 1,000,000 suns, but obviously that doesn't work. So there has to be something wrong with classical physics. And then Niels Bohr and Planck and slice of spam. I like that. That's funny. Okay. So where were we? Okay, sorry. We're going to talk about bound states. So bound states are, if you lose your phone, you are not going to look for it at my place in Sydney when you live over in the US, right? So that's called a bounded state. The bounded state is you know where it's going to be roughly. You know it's going to be within here and within here. It's going to be either in my car or in my house, right? You know that's called a bound state. And bound states are simpler, because if you lose your phone, it's obviously much simpler to narrow down where you're going to look for your phone, as opposed to saying, I'm going to look over all of the United States and I'm going to go knock on every single person's door and look for the phone. Right, that would be ridiculous. All right, so therefore, what we're going to do is start with bound states. So bound states is we know where we're going to look for the particle. Okay, and now that I've explained that, here is the theorem. The theorem is this. If V of x, in other words, the potential of x, the particle, is everywhere finite, okay, then both phi of x and phi dash of x are everywhere continuous. Now, what does that mean? That means that it's possible that your phone could exist everywhere you're looking for it. Okay, that's all it means. Now, that's a very simple, it sounds simple, but it's actually not really. But you do it intuitively. So when you look for your phone in your car, you don't look on the back seat behind the passenger but not behind the driver. That would be ridiculous. You look everywhere. Because why? Because you think that your phone potentially could be anywhere in the car. You don't think my phone could only be in the glove box. So that's the whole point. That's why that's called everywhere finite, which means that there is a possibility, exactly. There's a possibility that your phone could be in every single space in the car, right? Or it could be on every part of the seat, could be on the dash, could be on the back, could be everywhere, right? So you're going to look everywhere. You know where it isn't, but not where it is. I love that. Claricus, man, he's on the ball, this guy. Oh, man. I'm going to be like this 60-year-old dude, and he'll be like my age. No, he'll be older than me, but roughly. Still kicking ass, will be good. Yeah, that's exactly right. So that's why we call it everywhere finite. So in other words, everywhere finite means it's possible that it could exist everywhere. Is that superposition business? I forgot what that term means. Yeah, what idiot? Someone called Skelter or Stelter, some idiot in the news. He sounds like a moron, but he said superimposition, which doesn't even make sense. It's superposition. So I don't know what he was going on about. But anyway, yes, no, superposition is different. Superpositioning is the combination of multiple waves. So like when we talk, right, our voices are made up of many, many different tones that all together make it a rich tone. And that's why when you talk on the phone with someone, their voice sounds more robotic because the phone cuts out some of those frequencies, some of those wave distributions. So it's extracting certain waves from other waves. And that's called the reverse of superpositioning. I think it's superposition. Yeah, I'm not sure. All right. So why is that interesting? Well, mathematically, it's interesting because when we do our equations, listening to your own voice recorded, yeah, exactly. That's exactly right. Yeah. This part's going to be mathematics. All right. So basically mathematics, we're going to use calculus here, and calculus, we're going to have the derivative and the double derivative, or the first and second derivatives, right? Now you don't need to know what they are, but in mathematics we use them because it turns out that the second derivative, right, of the equation, if that is continuous, that means that the particle is everywhere finite. So in other words, imagine if, for example, imagine if you could find a mathematical equation that would tell you where to look for your phone, right? So, you know, the equation might tell you your phone will not exist in your neighbor's garden. It's only going to exist in your garden. So you know that it's continuous in your garden. So if you know that all of the possible points in your garden can be represented by one mathematical equation, and you derive that equation twice, if that equation is continuous, right, then you know that it's only going to be in your garden. So that's basically what I'm saying. And you don't have to get it more than that unless you love maths. If you love maths, I'm going to show you the equations right now. Okay. So, as we say, have a look here. When x, I'll wait for it to zoom. When x is less than negative a, in other words, when x is outside of where it should be, where we're going to find it, then phi 1 of x is going to equal a1 e to the kx plus b1 e to the minus kx. All right? Now, that means that the answer is complex. That means that it's probably not going to be there. When negative a is less than x less than a, in other words, when the particle is inside the square well, in other words, we can find it, right? Then you're going to get this. You're going to get a2 e to the I kx plus b2 e to the minus I kx. And when x is greater than a, you're going to get the same equation as up here, just with different a's and b's. All right? And k is that the square root of 2 times the mass by the energy over h bar. And I think I like Karen all of a sudden. All right, the square root, and k is the square root of 2m v0, which is the potential minus energy all over h bar. All right, so as we were saying, this is why, by the way, just to answer Karen's point, this is why more geniuses are men than women, because the smartest women in the world still want a man smarter than them because they're attracted to that. And women are the ones who decide which men get to reproduce. And so naturally, they're going to choose smarter men, and there's always going to be smarter women who will then choose smarter men. So as we move up the IQ scale over time, you're not smart. Obviously, most geniuses are going to be men, but also most knuckle draggers are also men. Never mind. So when they say men are smarter than women, that's false. That is false. The average IQ of men and women are the same. Was a genius. What is it with your former hubby? Your former hubby sounds great so far. I don't want to know the bad sides. The average IQ of, oh, I'm sorry to hear that. Jesus. Okay, well, that's not funny. Well, may he rest in peace, and I hope that you can find happiness again. I'm very sorry to hear that, God. That's talk about backfiring. Well, they're attracted to all of them because that's exactly right. We live in a multivariate universe. So ideally, like the ultimate man would be one that is unbelievably athletic and a genius and unbelievably empathetic and tall and good looking and healthy and financially very successful, right? But obviously that man rarely exists. And if he does, he can have sex with any woman he wants, right? And so I'm talking about one particular characteristic, which is IQ. Yeah. But obviously, this is why smart men by itself don't really get sex, but the smart man who looks good and who exercises every day, oh my God, like they have almost an unlimited supply of women. And that's also why men tend not to reproduce. In fact, your ancestors, and I've said this before, everyone's ancestor, like me, yeah, maybe. But I have autism, see, over a model any day. Wow. You should go into the library. You'll find them all there with their glasses and sitting around. So to answer Claricus, yeah, I lost my point. Sorry, man. I got distracted by these women saying these beautiful things. Yeah, sorry. If you go back in your ancestry, you will have twice as many women in your ancestry than men, because women can reproduce whenever they decide they want to reproduce with a guy. But guys really have to work for it, right? You have Asperger's. I have high functioning autism, my dear. So I'm not as genetically desirable as one may think. Okay. Now, these mathematical equations that we spoke about are only in one dimension. This is not helping the class. This is not. Thank you. I appreciate that. You have made my day. By the way, if you go to YouTube and you go to Gabsmack, you can see me reading you part of my book. If you like the book reading, I know I'm going to get sacked by Gabversity for talking to women. If you like the book reading on Gabsmacked, then you can pre-order a signed copy, because so far we have built up 10% of the signed copies we need. Liran's my best buddy. He's awesome. Claricus, I can see Claricus by the time he's 30, he's going to be... You know what's funny? I'll tell you what, Claricus, when I was 20, man, I used to chase women and they would never come after me, like barely. But when I hit like 35, oh my God, man, like women from 17, Ross from Friends. It's weird, man. Women from 17 up to 45 and 50, like it's just crazy. And it's so ironic because at 35 and 36, you want to actually settle down. And it's the same time that now all these amazing women, like beautiful, smart, successful women are chasing you. So it's just... All right. Now, here's what's interesting. We are only doing mathematics in one dimension. We're going to do three-dimensional mathematics and then four-dimensional mathematics. So it might get really boring for you guys later on. It might get too complicated and too boring. If it does, I really apologize, but I'll do my best to explain it as we go through. Right? Now, does anyone here actually have literacy in mathematics at all? How can that possibly be done? Bore me to bed. How can math carry over through dimensions? It's called vector linear algebra, yeah. It's called linear. If you ever do linear algebra, which I would love to teach you guys. I mean, it really annoys me that they don't teach that in school. So like people like Liran, who's now out of school, but people like Claricus, it's so obvious from me just talking to you the last two scopes that I could teach you university maths and you'd pick it up. It's so obvious to me. I reckon 90% I could teach it to you. That's why school's a waste of time, man. Honestly, it's so dumb, especially for guys, especially for smart guys. It's the waste of time. You could finish school at 15 and be at uni and have your degree by 18 and then go out and like just party for 5 years and work. And then at 23, come back and work, you know, and build yourself a future. Because guys, it's common. Oh, yeah. It's not just common core, but that's part of it, yeah. It's the corruptness that people overrunning the education system because, you know, the conservatives got weak and let the fake left take over. Oh, mate, I can only imagine. I got thrown out of almost every class. So from what you're saying, I feel sorry for you, man. I'm with you. I definitely get it. Yeah. So especially, mate, especially as you get older and you seem like, you know, you probably get a lot of girls going after you. How about matrix algebra? So did your dad. Yeah, I can picture that. Yeah. $100,000 charity challenge from Mike Cernovich has just popped up on my notifications. All right, let's get back to this because we're getting nowhere fast. All right, the mathematics now, this is going to be just mathematics, so you're going to get a bit bored, all right? Am I single? I am currently searching for the one, and I may have found her. I will let you know how it goes. But definitely, if you pre-order the book, it would be amazing, but only if you want to. And go to YouTube Gabsmacked and check the book reading. And I had people call me up telling me they were crying as I was reading the book. I think I had 6 people call me. It was insane. So we're going to get somewhere. Anyway, yeah, so I'm going to talk about young men actually in my speech, autism and young men. And this might apply to Claricus. The worst time to study for young men is between 15 and 18, because that's when you are out to try, I remember between 16 and 17, I almost had a constant erection. I mean, I hate talking about it, but it's embarrassing, but that's what happens, right? And everyone knows that, right? Like every guy knows that. It's freaking difficult, and it's all you're thinking about. So to then focus on quantum mechanics or, calculus at 17, and then especially if you're in a boys and girls school, yeah, it's terrible. Yeah, it is. Yeah, he knows, man. So someone and I can see your photo, man. Like when you reach 30, man, you're gonna have like every woman in the world running after you. So especially if you keep working out and stuff. Yeah. So I would say, man, you're pretty damn bright. If your parents can somehow get you to learn year 12 now and finish school by the age of 16, so you're not wasting time. And then all the 19-year-olds will be running after you and as well. Anyway. So we're going to have the boundary conditions. 4 boundary conditions. We have x equal plus or minus a, and 2 boundary conditions at x equals plus or minus infinity. Next trimester. You're a legend. Good on you, man. Well, let us know how you go. You could even scope some of your own subjects. I'll be proud of you. That's awesome. One normalization condition, namely the integral from negative infinity to infinity, absolute value of phi squared dx equals 1. You get a lot of girls. It's ironic because I don't want to get a lot of girls. That's not my mission. It was in my 20s, that was my mission, and I didn't do that well. But now in my 30s, I'm actually looking for one girl, and yet I get I don't know how many call me. So it's really weird. Anyway, this is really important for physics. The integral from negative infinity to infinity, the absolute value of phi all squared dx equals 1. Now, what does that mean? That equation, write it down. If you are good at mathematics, is it very attractive to a lady? I would say the combination of intellect, wisdom, and health, and good looks and exercise altogether really is a potent, deadly weapon. Yeah. But once again, I learned in my late 20s into early 30s. I talk about this I have another channel called Autism and Relationships, where I talk about all this. So if you're interested, you'll need to follow me on Gabsmacked, and you'll need to direct message me your interest and let me know your nickname on Periscope, and then I'll put you into the Autism and Relationships, and we'll talk about that. I won't talk about it here. So the integral from negative infinity to infinity of the absolute value of phi squared dx equals 1. Twitter. Oh no, on Periscope. Periscope, Gabsmacked. And then DM me either on Twitter or on Facebook. Facebook, I'm at Gabsmacked. DM, Twitter, Gabsmacked, yeah, and I'll put you in there. All right. All that mathematical equation is saying is that within certain borders, in other words, within the borders of infinity, you are going to find the particle. And all that is saying is that your phone exists, right? So for example, if you lose your phone, let's say I said to you, I lost my phone, right? And you start looking everywhere for my phone. Well, it's not going to help you if my phone doesn't even exist, right? You're going to be looking for something that doesn't exist. So therefore, that's what this equation means. This equation between negative infinity and infinity of the absolute value of phi squared, right? That means the probability, this is the probability of finding your particle in infinity equals 1. Okay, 1 means 100%. That means you're going to find it. It means it exists, right? If that is not true, then you're wasting your time. And that sometimes can exist, which we won't get into at the moment. There's a lot of people from Arizona signing up, which is pretty cool. Like the one. As we mentioned, the boundary conditions quickly tell us that B1 and A3 equals 0. So this is the mathematical stuff. We're not concerned with the overall normalization. Constant goal is to find E. That's very clear though. My husband is autistic. Oh, wow. Well, that explains why you like smart people. So we're down to 4 equations, the 4 unknowns. And that's where the matrix comes in, which someone asked about matrices. Furthermore, you know the Chinese came up with matrix algebra 1,000 years before Europeans came up with it, but the Chinese, being Chinese, kept it to themselves, the smart bastards. So, so Europeans had to come up with it themselves 1,000 years later. In fact, Isaac Newton actually could have discovered so much more if linear algebra existed when he was alive, but it didn't exist, which is so unbelievably sad when you think about it. Matrix algebra is multi-dimensional equations, and you can discover that's how the string theory works, because you use the 11 dimensions of 11 by 11 matrix, and they call them Hermitian matrices, 11 by 11, stuff like that. So here we have 4 simultaneous equations, 11, 11. The details are left for problem 10, but we'll get it here. Okay, so basically, here we are with the energy levels. So this is important. I'm going to show you the energy levels. All right. So here are this is energy 0, which really has no point. That means it doesn't exist. This is energy 1. This is the normal state. And you have that, then you have that, and that. All right. So the energy level messes with the wave function. Now I'm going to tell you what it means. The 5 states for a well of a particular depth V0. We've drawn each wave relative to the line that represents the energy En. All right. Both phi and phi dash are continuous at x is plus or minus a. When we talk about continuous, that means it's possible to find it in that location. That's what we're saying. And goes to 0, x is plus or minus infinity. In other words, it exists somewhere. If it wasn't 0 at infinity, that means it would exist somewhere beyond infinity, which makes no sense in this universe at least. I'm going to do a subject on abstract mathematics as well. The power supply, yes. Yeah, my phone keeps going crazy now. I get so many beautiful messages from you guys. It's such an amazing, beautiful thing. Like, so many people send me beautiful messages. I love it. The deeper the well, the more states there are. Consistent with equation 20, phi is needed oscillatory inside the well is indeed oscillatory. Okay. The curvature is away from the x-axis. As E increases, it tells us K increases, so the wiggles inside the well have shorter wavelengths. And also K decreases, so the exponential decay is slower. These facts are evident. The exact details of the waves depend on various parameters, but the number of bumps equals N. All right, so you don't need to worry about that at the moment. They're just teaching us that what N means, what K means mathematically, and then it helps us find the location of the item. So it would be the equivalent of having a GPS signal. So, for example, a GPS signal uses mathematics to calculate the location of something that's satellite tracked. And basically what we're doing now is working on mathematics to find out where a particle is. That's what we're doing. The next part is quantized energy levels. Quantized energy levels, and I think this will be the last thing we discuss today, but quantized energy levels, let's see who's here. We've got Kevin, Quantum, Karen, Mimi, David, Harry, Matt, Based, Deadhead, and Paint Something. That's funny. I love your names, man. It's so funny. And what's interesting is that more guys have a sense of humor than women. And not sense of humor, but the ability to make laugh, because guys needed that to attract women to them. Women don't need that because they're just hot. If they're hot, a guy's going to come after them. Present. To be. All right. So what we're going to talk about now, right, is the explanation of quantized energy levels. This is so important because we live in a pixelated universe, which means any mathematical equation in quantum physics is going to have a division by h bar or by h. And h basically is the size of a pixel of our universe. Now, why is that the case? Well, if it wasn't exactly that size, we would not exist. Nothing would be able to exist. Now, some people say God made it that way. Some people say, well, it's because there are an infinite amount of universes. So, of course, one of them, if she's not hot, then she'll have to be really good at sex or cooking or cleaning, or she'll have to pick a guy who can't get any better in terms of looks. Yeah, unfortunately, yeah, that's the truth. But love overrides that to a certain degree, right? Like when you want to put someone before you and you want to love them, there has to be some chemistry. But it's more important that you love them for who they are. Obviously, yeah. All right. I think I'm going to stop here. She'll have to be good at something. All right. I think I'm going to stop here and we'll do the explanation of quantized energy levels at a later date because I'm getting a bit tired and I got to go to work. So if you can, like I said, you pre-order the book or you go to Patreon/Gabsmacked, because then I won't have to work nights to cover doing all this during the day. That would be amazing. And then I could do even more scopes. And what else? I will put you into my private scopes as well. My Patreon guests and my GoFundMe guests come into the private scopes where I do a lot more scopes. In 4 hours, go to the gym. You're insane. But that's pretty awesome as well. My brother started going to the gym at 15 and he just got ripped as anything. Cook or clean or be with an ugly dude. Karen's hilarious. You have to be a Trump supporter. I find Trump supporters are the funniest people in the world, man. It's 1 a.m. Jesus, man, go to sleep. All right, I'm going to sign off then. I'll just study this myself. Doesn't sound fair. Life is definitely not fair. Don't insult you. Ah, there you go. Well, you have a wicked sense of humor. Oh, that's funny. All right, Bourgie. Uh-oh. Uh-oh, politics. No. All right, guys, I'm going before this decays into something. Love all of you, man. I don't care who you support. Love you all. All right, bye.